probability trees. Suppose that 90% of first class letters posted before 3 p.m. on a Tuesday arrive at the next day. Complete the following tree diagram to show the probabilities of what can happen when two first class letters are posted right independently before 3 p.m. on a Tuesday. So what you're looking at here, you're looking at 90%. So you can either do this, change it to a fraction and call it 90 over 100, which is 9 over 10, or you can do it as a decimal. 9 divided by 10 is 0.9. So probably a letter arrives the next day. I'm going to do it as a decimal, is 0.9. So the probability it doesn't arrive the next day is 0.1. The second letter would have exactly the same probability. So arrives the next day is 0.9. So it doesn't arrive the next day would be 0.1. Arrives the next day would be 0.9. Doesn't arrive the next day would be 0.1. And what we're going to say now is calculate the probability that exactly one of them arrives the next day. If I start here and go up, we want to find the probability it arrives the next day. So if I'm going up, that one arrives the next day, and that one arrives the next day. So that one up there means 2 letters arrive the next day, so that's no good. This one means you arrive the next day, and then don't. So that's good, because it gives me one option. The coming down means you don't arrive the next day, but then you arrive the next day, which is just one of them, which is good. And down means don't and don't. So what I got to do now is work out this one, and what you always do is times them. Do a 0.9 times 0.1. 9 ones are 9, and you got 2 places after the decimal point, so it becomes 0.09. This one will be exactly the same, 0.1 times 0.9, which is also 0.09. And then because you got 2 options, you got 0.09 plus 0.09, which is 0.18.